User operations are the core object of ERC-4337. They are the new transaction type that contains the instructions for what your user is going to do on-chain. We are going to cover the parts of a user operation, what happens when a user operation is submitted, how to use the user-op library to send an ERC-20 token, and how to send a gasless user operation. We'll start with the parts of a user operation. There are 11 fields in a user operation, but don't be overwhelmed. If you're using an SDK, such as userop.js, many of these will be filled out for you. The first field is the sender. The sender is the address of the smart account making the operation. The second is the nonce. This is a unique integer that prevents replay attacks. The nonce in ERC-4337 is two-dimensional, but most of the time you'll just increment it by 1. The init code contains the code to create the sender account if it doesn't exist. If the smart account isn't deployed, this code will automatically be executed at the beginning of the user operation by the entry point. Next is the call data. This contains all of the data that will be executed as part of the user operation. Now, the next few fields are all related to gas fees. Call gas limit is the maximum amount of gas for executing the call data. Verification gas limit is the limit on the amount of gas spent to verify the user operation is valid before executing the call data. Now, this needs a gas value because a smart account sets its own verification logic. It is a separate value because verification and execution are separated in ERC-4337. Pre-verification gas is the amount of gas to pay the bundler network for submitting the user operation on-chain. Max fee per gas and max priority fee per gas are the same as EIP 1559 transactions. Now, the 10th field is the paymaster and data, which contains the information about any paymaster that may be used and any data that the paymaster needs to sponsor the transaction. This can include a signature, an exchange rate, and so on. And finally, the signature field contains the data the sender smart account will check to make sure the operation is legitimate. This can be a regular ECDSA signature or anything else. Here's an example user operation. Once you have your user operation, you'll need to send it to the ERC-4337 mempool. This is usually done through a JSON RPC call to a bundler client. The bundler client performs some basic sanity checks on the user operation and then adds it to the ERC-4337 mempool. Bundlers watch the mempool and pick up valid user operations. The bundler does some simulation to make sure it won't lose money and then sends the bundle of user operations on-chain by calling the entry point contract. Now, a bundle is simply an array of user operations that is sent to the entry point. Now, this is where things actually happen on-chain. The entry point has two phases, verification and execution. It first enters the verification loop, where it checks that the user operation is legitimate. Now, at the beginning of this loop, the entry point checks if the sender account exists. If not, it will create it using the init code. It then verifies that the user operation is accepted by the sender by calling the validate user op function in the sender contract. Now, if a paymaster is used because the paymaster and data field in the user operation is not empty, the entry point will also check that the paymaster has sufficient stake in the entry point contract and agrees to sponsor the transaction. If there is no paymaster and data, the entry point will check that the sender has enough native token to pay the transaction. So that was the verification phase. Next is the execution phase. Execution is much simpler. The entry point again loops through each user operation, this time just sends the call data to the sender for execution and calls any custom fee logic in the paymaster. You can also have a component called an aggregator that can save gas by aggregating signatures for multiple user operations. The verification loop is slightly different if there is an aggregator, but we're not going to use one in this example, so we'll skip it for now. So to sum it all up, the user operation gets sent to the bundler mempool, where it is picked up by a bundler and sent to the entry point, which handles the verification and execution of the operation. Now let's actually build a user operation. Now, we don't need to manually create all 11 fields of a user operation because there are libraries that will help us do that. I'm going to use useropt.js. Here I have a node project using TypeScript. Let's start our script. I already know that I'll use environment variables, ethers, and some stuff from the useropt library. Useropt.js has a bunch of helpful presets based on common smart accounts, so you don't need to reinvent the wheel every time. We'll import the environment variables, and the smart account I'm going to use requires an EOA to own it. For brevity, I'll just use a private key for my environment to create the signer, but you can use a user's wallet from something like MetaMask, an MPC service like Web3Auth, or anything else. Additionally, you'll need the URL to send JSON RPC requests. Now we'll create our main function. We know we'll need to create a builder for the user operation, create the contract calls, and then send the user operation. Pretty much all user operations will follow this format. Now we'll create the builder. Useropt comes with some preset builders for common smart accounts. We'll use the kernel preset, which just needs a signer and the RPC URL. Again, the signer is just an Ethers wallet object. You don't need the user's signing key. So at this point, we have our builder object, which knows it's creating a user operation for a new smart account based on kernel. Let's run this to show the address, just to confirm that the builder is working. Great. Now let's create the calls that will be executed by the smart account. Our user operation needs to make two calls to the ERC-20 token contract, one to approve the token and another to send the token. To keep our code organized, let's put this in a separate function that we'll call approve and send token. This function will return an array of each call, in this case, approve and send. Both calls will have a to field, a value field, and a data field. In both instances, we're calling the ERC-20 token contract, which we're sending 0 ether. The data can be created by encoding the relevant functions from the ERC-20 contract. We'll import the ABI from a separate file. Ethers will need to get information about the token from the blockchain, so we'll also need to create a provider. Also, don't forget to set your types. We can now use the approve and send token in our main function. Let's just send the token to ourselves. Paste in the ERC-20 token address, and set the value to transfer to 0. We'll also print the calls to the console so that we can see that it worked. Great, everything looks good. Or at least it would if we could read hexadecimal like MetaMask users. To add these calls to the user operation, just call the builder's execute batch function. Let's view the entire user operation in the console by calling the builder's getOp function. Now it looks ready to be sent. Initiate a client from useropt.js. We'll use the client's sendUserOperation function to send the user operation to the ERC-4337 mempool. We'll also print the response so that we can just see what's happening. Now let's run our script. But remember, the account doesn't have any tokens, so we'll receive an error message that it didn't pay the pre-fund. We have the address of the sender, so let's just send it tokens. Let's do that now. Now that we have built a basic user operation and sent it, let's set a paymaster. We'll use the user-op paymaster middleware to do this. When we create our builder, we'll just pass some paymaster middleware. I'll create a paymaster URL environment variable and specify that I want to use a pay-as-you-go paymaster. This paymaster lets you pay for gas fees directly. Now, alternatively, you could set the paymaster type to ERC-20 token and select the address of the ERC-20 token the user can use to pay for gas. And that's it. We've gone over the parts of a user operation, what happens to a user operation when it's submitted, how to create a user operation, and how to send a gasless user operation.